We are going to discuss interference. What is interference? What are the conditions for constructive and destructive interference? What do you mean by coherent sources? And after that, we'll do Young's double slit experiment. We'll do the details of the Young's double slit experiment and we'll try to find out the expression for the fringe width. After that, we'll take what conclusions and what inferences we can get from that Young's double slit experiments there, and what type of different types of questions can be asked on that. So all these we'll discuss in today's discussion. Let's discuss what is interference. Interference is phenomena of redistribution of energy in a medium when the waves meet under certain specific conditions. So it is a phenomena of redistribution of energy in a medium when waves meet under certain specific conditions. Now, what are the conditions for interference? Conditions for interference. First one is two waves must originate from coherent sources. Okay, so the two waves which is going to produce interference there must originate from coherent sources. And what do you mean by coherent sources? Two sources we said to be coherent if their phase difference is either zero or it is constant with respect to time. So if their phase difference is either zero or constant with respect to time, then those sources we can say as that they are the coherent sources. And of course they must be having the nearly same amplitude, they must be having same frequency of the wave which is getting emitted there, they must travel with the same speed. So all these conditions is also must be satisfied. So here, second condition we can take, the waves must be of nearly same amplitude, same frequency, and must travel with same speed. Another condition, they must travel along same line or same direction there, or if along different lines, it must be at a small inclination. Okay. Then fourth condition, for constructive interference, path difference is integral multiple of full wave. Path difference is n lambda. That means it is integral multiple of full waves. And for destructive interference, path difference is odd integral multiple of half waves. So these are the conditions for interference there which we are getting. Main thing is that they must originate from coherent sources, they must be of nearly same amplitude, same frequencies, and must travel with the same speed. they should travel along the same line, or if they are along different line, it must be at a small inclination. And for constructive interference, path difference is n lambda, and for destructive interference, it is your odd integral multiple of half waves. So it is your 2n minus 1 lambda by 2. Let's take Young's double slit experiment. Now here we have S as the source of monochromatic light. It is a point source of monochromatic light. S1 and S2, these are the two slits having a separation d. Small d is the slit separation, distance between the two slits there. So S1 and S2 are the two slits. So as the wave is originating from S and is passing through these two slits, S1 and S2, so S1 and S2 will start behaving like two coherent sources. So here we have taken d as the distance between the slit and the stream. O is the point which is directly opposite to the point S there. And here P is your observation point. So wave from S1 and S2 is reaching at the point P. They are giving the superposition there of the waves, and they will finally give the conditions there for interference. So we'll just try to see what conditions we are getting for the superposition of the waves, which gives rise to interference here. So this observation point P is at a distance y. So this one OA, OB, all will be d by 2, which is just half, because this S1 and S2, they are equidistant from the source S. So now for the waves which is reaching at point P, the path difference, this will be S2P minus S1P. This will be the path difference. Now to get the value of S2P and S1P, if you take in the triangle, so in triangle, say S1PA, if I take this particular triangle, in that case S1P whole square will be equals to S1A whole square plus PA whole square, and this is nothing but your d square, and this is your y minus d by 2 whole square. So it is your S1P whole square. Suppose I call it as equation 1. In triangle S2PB, S2P whole square, this is your S2B whole square plus PB whole square. So this S2P whole square will be equals to d square plus y plus d by 2 whole square. This is suppose your equation 2. Now from equation 1 and 2, 2 and 1, S2P whole square minus S1P whole square, this is your d square plus y plus d by 2 whole square minus d square minus y minus d by 2 whole square. This is your S2P minus S1P and S2P plus S1P. This d square will get cancelled. Now it is your y square yd plus d square by 4. Here also it is your minus y square plus yd plus d square by 4. So these two terms again will get cancelled, and now what you will get? S2P minus S1P equals to 2 times yd divided by S2P plus S1P. Now here this can be written as 2 times yd by 2d. Why? As S2P is nearly equals to S1P and both are equal to d. So in that case this term will be equals to yd by d. This is the path difference. So it is equal to yd by d. So the path difference value we have got as yd by d. Now let's take for constructive interference. interference. We have seen that a path difference should be equal to integral multiple of full waves. So it is n lambda. So it is your y d by d, that is your n lambda, or y equals to n lambda d by d. So this will give you the position for the constructive interference. Now let's see, put here, if n equals to 1, y1 will be lambda d by d. We are putting n equals to 1, and this gives you the position of first bright fringe. Because on the screen we will be getting alternate bright and dark pattern there. If n is equals to 2, then y2 will be equals to 2 lambda d by d, and this is the position of second bright fringe. And in general, yn will be n lambda d by d. This is position of nth bright fringe. So this gives the position of particular bright fringe. Suppose it is asked what is the position of the third bright fringe. So you'll use this formula and put n equals to 3. What is the position of the fifth bright fringe? Put n equals to 5 and get the value. So this is how you can get the position of any particular bright fringe in Young's double slit experiment. For destructive interference, the path difference should be odd integral multiple of half waves. So it is your 2n minus 1 lambda by 2, and path difference we have got y d by d. So this is your 2n minus 1 lambda by 2, or y equals to 2n minus 1 lambda d by 2d. So this is the position of destructive interference there. Now again, if I put, if n is equals to 1, y1 will be equals to lambda d by 2d. This is position of first dark fringe. Similarly, if I take n equals to 2, y2 will be your 3 lambda d by 2d. We are just putting the value of n there in this expression. So this is the position of second dark fringe, and in general yn, this is your 2n minus 1 lambda d by 2d. This is position of nth dark fringe. So this is how you can get the position of any dark fringe in Young's double slit experiment. Let's now take the term that is called as the fringe width. Fringe width. Fringe width we normally represent by beta, and it is the distance between two consecutive bright or dark fringes. So it is the distance between two consecutive bright or dark fringes there. Let's now see what is the distance between two bright fringes. So if you have to find distance between two consecutive bright fringes, then we can get that one if you know what is the position of the nth bright fringe, and from that you subtract the position of the n minus 1th bright fringe. So we are taking yn minus yn minus 1. Yn, that means the position of the nth bright fringe, that is n lambda d by d. For n minus 1, it is your n minus 1 lambda d by d. So if I take lambda d by d common, it is your n minus n plus 1. and n will get cancelled, you will get lambda d by d as the distance between two consecutive bright fringe. Similarly, let's take what is the distance between two consecutive dark fringes. So again, this is position of the nth dark fringe minus position of n minus 1th dark fringe. So it is your 2n minus 1 lambda d by 2d minus 2 n minus 1 minus 1 lambda d by 2d, which is 2n minus 1 minus 2n plus 2 minus 1 lambda d by 2d. Again 2n and 1 will get cancelled. Ultimately, once again you will get lambda d by d. So whether it is the distance between two consecutive bright fringe or distance between two consecutive dark fringe, both cases you are getting the value as lambda d by d. So that means the fringe width value, we can write it as your lambda d by d. This is the expression for fringe width, lambda d by d. Lambda is the wavelength of the wave. D is, capital D is the separation between the slit and the screen. Small d is the distance between two slits there. So be very careful about the terms there, because many times conceptual type questions can be asked there. What will happen if the distance between the slit and the screen is increased or decreased? So in that case, you can see it is directly proportional to capital D. If the separation of the slits is changed, in that case, it is inversely proportional to beta. If we are changing the light, suppose the wavelength we are changing, if blue is replaced by red or red is replaced by yellow, so you can see how the wavelength is changing. Accordingly, you can say how the fringe width will change. So this is how you can get the expression for the fringe width, and you can apply for the different cases there. Now here, there are many expressions which we get, and the terms which is used there in this particular chapter. If you are not very careful, you may make the mistake, and terms will just appear to be very much similar. Intensity ratio of two sources or intensity ratio of interference pattern, slit width or width of slit. So be very careful about the terms which is used there in this chapter. Then only you will be able to answer the questions which have been asked on this particular topic. Like here, first term which we take, one is the intensity. Now intensity is proportional to amplitude square, amplitude of the wave square. So this is the one thing. Second, if it is asked as the intensity ratio of two sources, it means it is the I1 and I2 ratio. That is, the two sources are there and their intensity ratio we are taking. So obviously this will be your A1 square by A2 square. But if it is your intensity ratio of interference pattern, if it is the intensity ratio of interference pattern, that means on the screen when you are getting maxima and minima, bright and dark fringes there, so it is the ratio of dark fringe intensity to bright fringe intensity, or ratio of intensity of bright fringe to dark fringe there. So basically this is the ratio of I max to I minimum, and that means it is your A1 plus A2 whole square by A1 minus A2 whole square, or it may be your I minimum to I maximum ratio, then it is your A1 minus A2 whole square by A1 plus A2 whole square. It may be any of the formula, because if it is said that intensity ratio of the two sources or intensity ratio of interference pattern, in that case, it may be maxima to minima or minima to maxima. If you have to write the intensity ratio for any particular expression there or any particular problem there, you can write in any ratio, either maxima to minima intensity ratio or minima to maxima. But if in the problem it is given that this is the value of the intensity ratio of interference pattern, then you will have to justify or decide whether it is the maxima to minima ratio or minima to maxima. Like suppose if it is said that intensity ratio is 25:16. So here numerator is more than denominator. So obviously it must be the ratio of maxima to minima. If it is your 9:16, so now it is your minima to maxima ratio. So that way you should proceed. Another thing is that intensity is proportional to width of slit, which they represent it as W. So it is the intensity proportional to width of the slit. Now here be very careful. It is the width of the slit which is given. That means if now you have suppose the two slits, one is this particular slit, other is the another one. A small d which we have used is the slit separation. So we have used two terms, width of the slit, that is W, and slit width, this is your small d. So the distance between these two slits is a small d, whereas width of the slit means it is the opening of this particular slit. If this is the slit there, what is its opening? That is your W. So obviously if the opening is more, width is more, definitely more amount of intensity of the light will be coming out of it. That is why intensity is proportional to width of the slit. So with that, if you get, you can write the expression I1 by I2. This will be your W1 by W2. If you have to compare the ratio of intensity if the width of the slits are given. So in that case, this term, be very careful when it is being used, whether it is the width of the slit or slit width, what has been given, and accordingly you should proceed. More formula you can get if suppose we have two waves and they have the amplitude say A1 and A2, and these two waves are meeting at a particular point. And if now we want to find what is the intensity of the resultant wave, A1 and A2 are the amplitude of the two waves which is meeting at a particular point. So due to superposition, if their intensity is represented as suppose I, then this is your A1 square plus A2 square 2A1 A2 cos phi. Phi is the phase difference between the two waves there. Now we know that I, that is the intensity, is proportional to amplitude square. So what we can write? It means if it is your A1 square, A2 square, that means this particular term will be like I1, I2. And here, this is like 2 times root over I1, A2 root over I2 and cos phi. So many times this formula also can be given there to use, where you have to find the intensity of the resultant wave. When the intensity of the individual waves are given, their phase difference is given. So this you can use there. Also, you know that for 2 pi phase difference, the path difference is lambda. So for 2 pi phase difference, path difference is lambda. Therefore, for unit amount of phase difference, the path difference will be how much? This is your lambda by 2 pi. So for phase difference delta phi, if you want to find path difference, the corresponding path difference will be equals to lambda by 2 pi into delta phi. So that also we can use. So this is there in Young's double slit experiment, there expression for the fringe width, expression for the intensity, there intensity ratio of the two sources, intensity ratio of the interference pattern there. Okay, so all these things there related with Young's double slit experiment.